We begin this video with two useful information. The first information, if a number n has 4 digits, then n is between 1000 and 10,000. If a number 2 power n has p digits, then 2 power n is between 10 power p minus 1 and 10 power p. We observe that when the power is 4, then n has 4 digits. So when the power here is p, 2 power n has p digits. Now for the second information, we examine this table. The table contains the values of powers of 2. We have 2 power 0 until 2 power 63. There are 4 powers with single digit. That is 1, 2, 4, and 8. Single digit. 4 powers of 2. 2 power 0, 2 power 1, 2 power 2, 2 power 3. Then we have 3 powers of 2 when there are 2 digits. 16, 32, 64. So there are 3 powers of 2 with 2 digits. Then if we continue for 3 digits, 1, 2, 8, 2, 5, 6, and 5, 1, 2. We again have 3 powers of 2. 2 power 7, 8, and 9. 3 powers of 2 with 3 digits. There are 4 powers of 2 with 4 digits. 1024, 2048, 4096, 8192. 4 powers of 2 with 4 digits. Let me make a correction here. 3 powers of 2, 2D, 3D, 4D. Okay. In this rectangle, we have 4 powers of 2. And all this have 1, 2, 3, 4. 13 digits. 13 digits, we have 4 powers of 2. If we go further down the table, 2 power 57, 58, 59, they have 1, 2, 3, 4, 5, 6, 18 digits. So we observe that the numbers of powers of 2, the number of powers of 2 is always 3 or 4. Okay. This is what we are going to prove in the video. The headroom method. Proposition. Given an integer p such that 2 power n is between 10 power p minus 1 and 10 power p, there are either 3 or 4 values of n. This is equivalent to saying integers with p digits have only either 3 or 4 powers of 2. Look at this 2 power 7, 2 power 8, and 2 power 9. These all have 3 digits. And those with 4 digits, we have 2 power 10, 11, 12, 13. There are 4 powers of 2 with 4 digits. 3 powers of 2 with 3 digits. These are examples. We can also write equivalently between 100 and 1000. The powers of 2 with 3 digits, 2 power 7, 8, 9. Yeah? So 3 values of n. If we consider the interval 1000 to 10,000, we observe there are 4 values of n. 2 power 10, 11, 12, 13. Now, the headroom method. 2 power m, let it be, have a headroom, have a headroom of h more than 10 power p minus 1. So the headroom method uses 2 power m equals to 10 power p minus 1 plus h. And we are going to show two things to show in the interval between 10 power p and 10 power p minus 1. If h is less than a quarter of 10 power p minus 1, there are 4 powers of 2. If h is greater or equal to quarter of 10 power p minus 1, there are 3 powers of 2. These two assertions, we will now show the proof. You start with the headroom, 10 power p plus h equals to 2 power m. If we multiply by 8, then we have 2 power m plus 3 equals 8 times 10 power p minus 1 times 8h. 2 power m plus 4 means we multiply 16. So we get 16 10 power p minus 1 plus 16h, which we know 16 is bigger than 10. So the value is greater than 10 power p. If we consider the second line, we have 8 10 power p minus 1 plus 8h if less than 10p. That means 2 power m is inside the interval less than 10 power p. 2 power m plus 3 is inside here. If that's the case, we notice 8h equals to 10 power p minus 8 times 10 power p minus 1, which gives us 10 minus 8 equal to 2. So 2 times 10 power p minus 1. So h is a quarter of 10 power p minus 1. So when h is less than a quarter of 10 power p minus 1, 2 power m plus 3 will be inside the interval. So we have example for the h28, when h is 28, then it's more than 1/4 of 100. Then there are only 3 values. The fourth value will be outside. Okay, when we have 2 power n is between 100 and 1000. The first power is 2 power 7, which is 128. So the headroom is 28 and is more than a quarter of 100. So it's the second condition. There are 3 powers of 2 only. 2 power 7, 2 power 8, 2 power 9. 2 power 10 is 1024, is outside the interval. If we take the interval 10 power 3 to 10 power 4, the 1024 to 8192, let's take. Then h is 24. 24 is less than a quarter of 1000, which is 250. So we have a very small headroom. This allowed the interval to contain 4 powers of 2. 2 power 10, 2 power 11, 2 power 12, 2 power 13. The next power will be outside. So we notice that the boundary, 1/4 10 power p minus 1 is the boundary. If less than the boundary, we have 4 powers of 2. If the headroom is bigger beyond the boundary, then there'll be 3 powers of 2. We will next show that the power will never be 2 or 5. The number of powers of 2 can never be 2 or 5. There can never be 2 powers of 2. We have the headroom H again, or 2 power m. So 2 power m minus 1 is smaller than 10 power p minus 1. If H is large, is it possible to have only 2 powers of 2? If H is large, that means if 2 power m minus 1 is close to the 10 power p minus 1, then H is large. Is it possible that only 2 powers of 2 occur? So we let 2 power m minus 1 be less than 10 power p minus 1, and 2 power m be the first power more than 10 power p minus 1. With the headroom H, since 2 power m minus 1 is less than 10 power p minus 1, if we multiply by 8, then we have 2 power 3 times 2 power m minus 1, you get 2 power m plus 2, which is 8 less than 8 times 10 power p minus 1. 8 is less than 10, so obviously it is less than 10 power p. So we have this headroom H here. 1, 2, 3. This shows the 3 powers of 2 in the interval. So there can never be less. There can never be less than 3. So there can never be 2 powers of 2. Okay, 2 power m minus 1 is less than 10 power p minus 1. After that, we notice that after we multiply by 8, the third powers of 2, which is 2 power m plus 2, is still less than 10 power p. So this ensures there are 3 values, 3 powers of 2 in the interval. It can never be less than 3. There are 3 powers of 2. There can never be only 2 powers of 2. There can never be 5 powers of 2. We say there are always 3 or 4 powers of 2. We will now show there can never be 5 powers of 2. Again, with the headroom H, we know 2 power, no matter how small, we want to make this H as small as possible to have more powers of 2 inside the interval. But 2 power m is more than 10 power p minus 1. If we multiply by 16, so we get 2 power m plus 4. 16 times 10 power p minus 1. 16 is more than 10, so we get more than 10 power p. This shows the power 2 power m plus 4 is outside. It's beyond the the end point here, 10 power p. So we have up to 4 powers of 2 inside the interval. There can never be 5 powers of 2. So the 4 powers of 2, 2 power m, m plus 1, m plus 2, m plus 3, yeah? There can never be 5 powers of 2. So we make the conclusion, when 2 power n is between 10 power p and 10 power p minus 1, there are always 3 or 4 values of n. For integers p with p digits, there are either 3 or 4 powers of 2. That's the end of the video.